Okay, most welcome to our class of the day. Today we have very interesting and attractive topics which relate to the sequence. We are going to study what you call the sequence character. We have a question which said, define the sequence where have u0, it means the initial time equal to 2, we have un plus 1 equal to f of un, which is equal to un plus 1 over 2. They have asked to check whether the given sequence lies between 1 and 2. The second one, they have had to show that if the sequence is a monotonicity decreasing, simply means if the given sequence have a monotonicity. The last one, they have already asked to check whether the given sequence can already exist, means that they will use the convergence and define the limit of a given sequence if it is possible. You really know well that for finding the limit of a given sequence, we have to apply the limit theory character, where any given number of terms is tending to infinity. Okay, let's go on the next slide. When you go there on the next slide, you have an expected response. When you go there, about their limit is equal to 1. We have got about their convergence, means that they can be divergent or convergent. We have seen that our sequence is convergent. About their monotonicity, it is decreasing. You can already think if it is the expected response. A boundary. When you take like when you given sequence n is equal to 1 and the equation you given data un plus 1 equals to un plus 1 equals un plus 1 over 2. Remember that initial term u0 is equal to 2. This simply means that the first n equal to 0. When you replace the n equal to 0 on the given data, you will get is u0 plus 1 is equal to u0 plus 1 over 2. Remember that u0 is equal to 2. This simply is u1 will be equal to 2 plus 1 over 2 is 3 over 2 is 1.5. 1.5, this is between 1 and 2. When you go there on the upper limit boundary where you have 2 and you try already even to place there, all that are given lie between 1 and 2. This simply means that the first property is verified. It's verified as it is required. Let's go there on the next slide. The conclusively find out by induction method the given sequence lie between a given interval. Let's go there on the next sessions or the next slide about for finding monotonicity of a given sequence. We have is check whether the given sequence is increasing or decreasing. I know that well you know the property. If you really want to check whether the given sequence series un plus 1 over 2 less or equal to un, if it is verified or possible, this simply means that our sequence is decreasing. Okay, try to check or find. Even already take a un which is anyone you want. Let's already even take like un which is equal to 2 Mara, and you press there, you get 2 plus 1 over 2 less or equal to 2. You get 1.5 is less or equal to 2, where un is equal to 2. This property is well verified. That simply means that finally, conclusively, our given sequence is decreasing. Then On the last part is for finding convergence and finding the limit. Remember that our sequence is decreasing. It is bounded below by 1. And by monotonal convergence theorem, this simply means that let's limit n approach to infinity un equal to r. Remember that un, it is given in terms of a function f. When you replace those given that are there, where un is equal to, is already even given that un plus 1 is equal to f of un, where f of un is equal to, when you remember f of un is equal to un plus 1 over 2 on the given equation. This simply means that when you go there, you will get that un plus 1 is equal to r. Even un is equal to r. When you replace those values there and you make cross product, finally you will get that r is equal to r plus 1, which is equal to 1. Then by solving this expression, r will be equal to 1. This simply our final solution asked is this one, and you will get that un is already valid between 1 and 2 as it is required. Then un is decreasing like monotonicity, and their limit is tending to 1. Thank you very much. All the best.